Unit 4, D block elements, blueprint. Part 1, 2 1 mark question. Part 2, 2 3 marks, 35 and 36. Part 3 mark question, 1 5 marks, 53. Part 4, 1 5 mark compulsory problem, 70B. Under the D block elements, first of all, we have to justify one element, whether it is D block or not. The penultimate shell, the d orbital of the penultimate shell must be partially filled. Then it is called as D block element. For example, suppose n is the last shell. Then n minus 1 is called penultimate shell. Its d orbital must be filled from 1 to 10. Last shell 1 to 2. This is the general electronic configuration of d orbitals, d block elements. These d block elements are showing colored ions. Suppose the d orbital, there are 5 orbitals in d. Suppose they are having partially filled electrons, electron will be jumped from higher level to the lower level. While jumping from higher level to the lower level, they emits the energy. You think in the reverse way. Suppose they are jumping from lower level to higher level, it needs some energy to do so. In order to do so, it absorbs the energy from the surroundings. It absorbs the energy from the light and gives the corresponding color. For example, the titanium 2 plus is purple and V2 plus is violet. Cobalt 2 plus is pink. So, the unpaired electrons leads to the colored ions. Most of the D block elements are used as a catalytic properties. They are used as a catalyst. Then they are showing variable oxidation state. Suppose you are considering alkali elements, electron have been lost only from s orbital. That's why they are having only one type of oxidation. But if you consider any of the D block element, they are also called as stanchion elements. Since you are moving from s orbital to p orbital, s orbitals are highly reactive. P block elements are less reactive. So if you move from s block elements to p block element, it acts as a bridge in between these two. There is a transition from highly reactive to less reactive. That's why they are called stanchion elements. In stanchion elements, electron have been lost from two different orbitals. One is n-1d and ns orbitals. The n-1d and ns orbital more or less having the same energy. That's why electron have been lost. Then they are showing magnetic nature also. Paramagnetic and diamagnetic nature. The magnetic moment have been calculated by using this formula, where n is the number of electrons, unpaired electrons. Bm is called Bohr magnetron. It's a unit of this. And it forms complex. Complex means there must be a small central metal ion likewise. This could have been surrounded by different groups called as ligands. The ligands are donating a pair of electrons to central metal ion. So there must be the space inside the central metal ion to arrange the electrons given by the ligands. So the combination of central metal ion and all the ligands are called a complex. So a complex is made of central metal ion and ligands. Then they are forming alloys. Two or more metals combines to form a very strong metal. That mixture is called alloy. Chromium is a very important element which has been considered in transition elements. And copper is another one. Copper is extracted from the principal ore, copper pyrite. Copper pyrite is the sulfide ore, CuFeS2. The sulfide ore is concentrated by Froth flotation process. Then it has been roasted. While roasting, all the impurities have been evaporated. The copper involves very important conversion factor called as bessemerization. In electrolytic refining, impure copper has been made as anode and pure copper has been made as cathode. Copper sulfate solution acidified with sulfuric acid has been taken as the electrolyte in this case. Copper reacts with chlorine to form CuCl2. Chromium. The chromium is extracted from chromite ore, oxide ore. The oxide ore is concentrated by gravity process. Next to the chromium, you are having zinc. The main ore of zinc is zinc blend. It is Z and S. Z and S is called zinc blend. Since it's the sulfide ore, it is concentrated by Froth flotation process. Initially, the ore is crushed and ground and the powder is concentrated by Froth flotation process. Then it is fried. It is roasted. When zinc sulfide is heated in the presence of oxygen, the sulfur is replaced by oxygen and you are getting Z and O. And sulfur dioxide has been eliminated. It has been eliminated like this. 3 wood. The process of heating one chemical, the process of heating ore in the presence of the supply of oxygen is called roasting. So it is roasting. Upon roasting, the sulfide ore is converted into oxide, first step. Then from this zinc oxide, the oxygen has to be removed. Removal of oxygen is called as reduction. So it is reduced in the presence of copper. So zinc metal and carbon monoxide is formed. This is the extraction of zinc. Then the zinc reacts with sodium hydroxide. Zinc reacts with alkalis. Suppose it reacts with NaOH. It forms Na2 ZnO2. It forms Na2 ZnO2 and the hydrogen is liberated. Shall we balance this? It is called sodium zincate. Sodium zincate. Then silver. Silver, the main ore is argentite.